Hello, BCW20 Day 2. So the power of digital twins for building automation operations. It's a question that we asked ourselves almost a year and a half ago. So really, can you bring operations of building automation a little bit more transparent? Because it turns out these things are quite complex in interplays, because there's a lot of domains that need to interact with each other. So can you use the idea of semantic captured goodness and digitalize them in a way you can execute them, and at the same time, all the things that happens in reality, because there's still reality out there, you get the information flowing into these digital models in time and space, and they give you value. Okay, so that's the thing we want to talk about. Now, the goal here obviously is clear that we set out for us. Can we empower complex physical systems to be intelligently operated with transparency and at the same time gain these valuable insights that we all need in order to operate these systems to its highest efficient level, so that we can not just sustainably think and care about environmentals, but also about the shortness of highly skilled talent. Now, Habib, can you put some context for us here? What kind of things we're talking about?
Sure. And also welcome everyone, and each and every one of you. It's amazing to see that many people here. I'm really excited. Thank you for coming. Last year, and I'm not sure who's been here last year, we showed you how a building could be experienced if you would just leverage the data that these three classical building domains that we operate in provides. If you missed that, you're welcome to look it up on YouTube. There's a little presentation out there. This year, we have the privilege to give you a deep dive into the perspective of a building operator who has the responsibility to operate a heating, ventilation, and air conditioning system, in short, HVAC. I know this sounds a little bit like me talking about hot air, and this is one of the biggest IoT events in Germany. How does that even make sense? But stay with me for a little bit. I'd like to take you on a trip to a different place. Welcome to Climatech, our building automation subsidiary in the US, located in the beautiful state of Arizona. The headquarters in Phoenix is a perfect location to give you an impression of what it takes to efficiently and comfortably operate an office space. There, since well over 40 years, we are designing, building, and maintaining building automation and control systems for heating, cooling, and ventilation, for our customers, and obviously for ourselves. This is a real-world laboratory where we operate a representative cross-section of all sorts of technologies that were introduced into the markets over the years. The multiple building domain operation systems doing their job, but they are usually rather disconnected and designated for a particular use case only. Somehow this is acceptable because this is state-of-the-art building technology today. Likewise, the challenges we are facing in operating these systems are the same challenges that each and every one operator faces who has to operate a building technology system today. Now, the HVAC equipment, the heating ventilation equipment you saw in that video, is usually operated by a designated building automation system. And these systems provide you with visualizations like this one. It's a little tricky to find the right value if you need it quickly. But it gives you a good impression of a moment in time on operation, and you're able to do what is needed to run the system. These systems also, as you can imagine, generate a lot of data along the way. This data, some of it at least, is stored in a workstation, and this workstation usually sits in the basement of the building, and there sits the data, and it's lost.
Yes, and exactly, these are the domain-specific perspectives that everybody that talks and speaks building automation all day and night long knows what that means. In particular, there's plenty of these beautiful data, and it turns out that these data, they also do have semantic meaning. So the 42s, if you like, We call them time series because they are data that just flows into these systems all day, all night long. And it turns out that today what we do is we tag these data with semantic meanings, and it's quite labor-intensive, and domain-specific experts need to do that on site. Okay, so that's what we usually do, and we have shortage of those people. So Habib, it's kind of like a black box, isn't it?
Yeah, well, in case I need to find some details or understand a system, it's really like looking at a black box. Me as a building operator, I'm not an IT expert. Looking for data becomes tricky, and understanding really the system is hardly impossible. So most of the time, it is very time-consuming and a manual process to find a solution to a problem. Mainly, we leave the systems running as they are until they fail.
That's not so much good experience. So how about we can make this a little bit more transparent? How if we can crank up this black box of Pandora and actually have this transparency inside of what happenings on the real site? Things like I can do proactive, predictive, and prescriptive actions in order to operate these systems the most efficient way. And even make this experience operator-friendly. Wouldn't that be a cool thing, Habib? And what is it that we would need to do in order to get there?
Yeah, well, as we heard before, to really get to this transparent experience, we have to get everything in the right context, the building and the system alike. So getting there, we have to talk about the life cycle. And we do, in the construction and building industry, have a lot of digital twins in all these different phases.
So you mean there's not just one?
No. The one we need for what you're suggesting is actually one that should focus on operation and maintenance. The one in the building space, in the construction phase, is most of the time useless. So look at this, for example. This is a cross-section of the building we've just seen in the video. It has rooms, spaces, meeting areas, working spaces, doors, windows. This is one context that I need to understand. The other one is the HVAC equipment that serves this place. There's electromechanical systems that sit around the building, on top of the building, distributed throughout the building. And you have this building automation system controlling it and trying to negotiate the temperature with the system that it can provide. So look at this. Isn't that already a beautiful 3D model, a digital twin?
Yes, for some, I guess it is. And this is part of this beautiful Phoenix, Arizona building you saw at the beginning of this reality, because reality still exists. And you could say that this is a beautiful 3D model of this reality, and for some people capturing it BIM or CAD design, this is a digital twin, but it just captures a static view of it. There's something missing. If we want to make operations clever and intelligently, you need to not just connect these things into the digital, but you also have to have a way to articulate these. For instance, is a space, it's an office space. It consists of rooms, and rooms are in floors, and rooms may have doors, and they may have windows. And then look at this beautiful HVAC system. I started to like these HVAC systems because I understood how complex they really are. So they have pipes and chillers and cooling towers and air handler units and all the things that these domain experts talk all day, night long. Turns out in operation it's quite difficult because it's mechanical, it's electromechanical, and these kind of things drift over time. Okay? So what we do is we capture the know-how of these domains in what we call semantic models. And they describe now what the wall is and how the rooms are connected to the building and how the floors are related to it. And it also describes how these HVAC systems relate to each other. So what's the cooling tower relation to a pipe versus an air handler unit versus a volume flow transmitter, to just name a few of them. Okay? And these, if you like, are blueprints now to instantiate and glorify the digital twin instance that connects the real world into that digital execution space. So we can get the semantic, intelligent insights out of these operations. Okay? Now, this is not yet completely the twin, though, because, as we know, these buildings have a geolocation kind of coordinate system. So they are somewhere on this planet Earth, in space, in time, and they have heights and widths. And so there's geolocation information, okay? And the same is true for the building automation system. Sometimes I get asked by my daughter, Dad, what did you do in the 80s when you were driving from A to B without Google Maps? I said, well, there wasn't a digital twin of Earth back then. So we had this thing called paper maps on our knees, and we were driving through big cities and trying to find our way to targets. It turns out this is pretty much what we're trying to do here, right? So we have a description of the real world captured somewhere, and today, if you know a geo-information system, is pretty much the capturing of Earth. And we're trying to do this here for the domain perspectives. Is that yet a digital twin for operations? Well, the combination of it is, okay? So the semantic models applied to a physical site, which is physical equipment, is what we call the digital twin for operations. And that's a different digital twin than the ones that you use when you're just drawing in CAD tools, okay? Makes sense?
Makes sense, it's beautiful, but how do I now connect my physical systems with this?
Glad you ask, because still equipment sensors, they need to get connected. Remember, reality gets to get connected to the digital, and that's the talks we have been talking in the last years in IoT conferences such as this. You know, all of the protocol goodness, the data normalization, how do you bring the 42s, make them look pretty into this digital kind of execution space. So, of course, this is also required.
Okay, that makes sense.
Yeah.
So when I apply a comprehensive description of a space to a given building, and a comprehensive description of a system to a given installation, I actually get to this meaningful insight and all these relations. Did I understand that correctly?
Yes, right. And you may ask, does that just apply for this kind of building structure for the headquarters of Phoenix, Arizona? No. Because the power of these semantic models captured as standards, put into repositories, make open for the public wild, I can now apply this to any kind of building type, universities, hospitals, hotels. We don't really care, because a building is a building at the end of the day. It just differentiates by the means of its, topology. The same is true for the HVAC systems. They still, all these things apply. It doesn't really matter of the size of the building, okay?
Yeah. So I see, it makes sense. And the data points that I showed you earlier now are not just data anymore. They're meaningful information that I can exploit now because I understand the relationships and their origin.
Yes, exactly. So, for instance, on that picture to the right where the hospital is, this temperature sensor down there at the OP room, exactly when this data flow into the system, the 42 value automatically knows it's a temperature, it's in Fahrenheit, it comes from the US, from a hospital, in an OP room for a certain surgery. So this is all contextual, sensitive, captured. But we don't stop here, of course, because we have so much more domains to project into these buildings. So of course you may ask, do I only have 2 potential domains possible to get integrated? No, of course not. Many more to come, such as energy or physical security, that we want to project after the fact to this building operation, and we can by the models that we have applied here.
That's a great concept, I really like it. But honestly, man, have you ever tried to do this in the real world?
I knew you were asking that. Yes, actually we did. And it's a lot of, this conceptual goodness. And I guess that's also when people talk about digital twins, the conversations can go a lot of directions. And it's very hard to have a conversation that gets you to this target space that you really want to be. And therefore, when we thought about this, it was so important for us to have this storytelling in order to transport the things that you now see. So please be mentally ready, because what you now see is I will walk an instance of this digital twin for the Phoenix, Arizona Climatech headquarters in life with you. So a digital twin with all of those domain perspectives instantiated in time and space and being executed somewhere. Okay, it doesn't matter really where. I can tell you where. And this is being represented as a graph. It's a graph of nodes, And each of those nodes, they have their context informations, they know with whom they belong, with whom, for what reason, and where, in what context, in which process execution, and with what people may be involved. Okay, ready? So this is the digital twin in its glorified prettiness. So this is Climate Tech, and I walk to the headquarters, and I go to floor 1 and to my favorite place, the cafeteria, going by the name D117. Okay, and each of those nodes have contextual sensitive information. They know that they are a room, a cafeteria in Climate Tech headquarters. There's a volume flow transmitter D6. It is of a certain type. It knows that it has sensors connected. 101 is a temperature sensor measuring Fahrenheit in absolute values. So it has a 74 degrees Fahrenheit at this given moment in time. And it's air, and it's about an absolute measurement sensor. Easy. Once you have these graphs, you can now start to ask kind of questions to the graph. Give me all the rooms that have a temperature over a certain amount of Fahrenheit value that was set to another value, but all of the rooms that did not have this value as expected, and tell me what was wrong with the equipment and give me all of the anomalies that happened to cause this. Easy questions, right? I think you all can answer them in your current automation systems. To make this more automized, highly digitalized, is the base foundation that gives us all these kind of things. But this is the here now, but what happens with the past? So if I look at the time series here, powered by a data explorer in the background, I now have all of those data points, and they have contextual semantic meanings. It's no longer a soup of data points that I need to go fish and try to find out after the fact what they mean contextually and semantically, okay? So that's another power that we get. And each of those points in time, they already have semantic meanings. We don't stop here. So let's say we have 80 million data points by the time when we captured this, powered by the data explorer goodness from our friends Redmond. I can detect anomalies like a Bosch of D117, giving me all of the anomalies that have happened over the past week or so in that kind of operation. And I can also ask this system questions. What is the prediction about temperature and the behavior of the system moving forward? Okay. And because these are all pretty much technology perspectives, bear with us. We make it easier. So we design these beautiful cockpits, okay, that the operators of tomorrow, which may not be the hardcore domain experts that know every single backnet data point by its name, D117, we have an easier kind of view of class for them. So you see here, I can now walk the system, I can experience the map, the landscape, the topology I was talking about. Each of those things has real-time values. I can drill into it. I can go into investigation mode. Now I literally walk the digital graph of the digital twin and try to find interrelations with the nodes that tells me this is a AHU and it's being served by a plant and so on and so forth. So you see the power that comes alive to surface, powered by this digital twin in the back. Nobody really wants to know how the digital twin looks like at the end of the day. What you care is about this operation, and for sure you have an easier way to ask the system, what is the prediction here for the future? And I can even then, at a complete, comprehensive summary of the system, look at what's my overall building status, how was energy consumption, how about maintenance plans for a certain piece of equipment, how about the comfort level of the overall experience in the room, what about the air quality after all, over time. I can give a complete, comprehensive overview about the issues that have been happened, issues that will happen, and how they have been kind of solved. Now, of course, people always ask, and is there any other business value in this, Habib?
Sure. I mean, this is really impressive, and if you compare this to the dashboard I showed you in the beginning, it makes a lot of sense, because now I have this contextual background, I have history, I can even look into the future. And man, this is tremendously valuable, because now I can think ahead of when do I need to replace stuff, order maybe parts, and even predict how this might affect my bottom line. So there's a big economic value in such a perspective. Thank you very much.
If there's nothing you take away from this, we want you to leave today with 3 things. 1, Automation systems are complex in operations. It doesn't matter if it's a building automation system or it's an industrial automation process that's happening in an industrial manufacturing plant. No difference, really. 2, you really can leverage the power of semantic capturing. So take your domain expertise, because this is the gold of tomorrow. IT systems, cloud systems are commoditized. Okay, we have industry players that know how to do this. What we know is how to leverage this domain expertise, packaging them, make them available to the public, create standards, and make the difference for the customers by leveraging these standards in semantic models. 3, the digital twins is just the means to bring all of this to a surface from which you can get the power of its execution and insights from. And ultimately, this gives you analytics capabilities for the here, the now, and the past. So with that, we have 3 more pointers for you. Last year, we set the stage for our Building Intelligence as a Service program from Bosch Building Technologies. You can get this talk on this YouTube channel there. We have our friends from Bosch I/O with the connected building services that we do work together with, as well as with the Microsoft people. We do use a lot of Microsoft cloud services here. And then, if you want to follow us along, in the middle there is the link to Bosch Energy and Building Solutions, where you can follow us. So with that, we thank you very much for your attention.
Thanks a lot.
We are Andreas and
Habib.
Thank you.
Have a great day.